Hello, in this video I'm going to show you how to create a publisher node for the Autominy vehicle, the autonomous car. And first to do this we have to open or to execute the simulator of the autonomous car. To do this we recall that we have to use the command launch Autominy Simulator.launch. So we execute this command to open up the simulator of the Autominy car. We wait a little bit for the simulator to open up, and then there we have our simulator. We can move the screen to visualize the autonomous vehicle, and there it is. We have the autonomous vehicle there, and now we can open up a new terminal to verify that we have access to all the topics with this simulator. To do this, you can use the command topic list to obtain the list of all the topics that are available with this simulator. And again, we're going to focus on two topics, actuators speed topic and also the actuators steering normalized topic. These are the two topics that we are going to use in our program for our publisher node. But first, it's important to know that there is some information that we need to create our node. Specifically, we have to know what are the type of messages that we have to publish on these two topics. So we obtain this information with the command topic info at the name of the topic that we want to know. In this case, we are going to use actuators speed to obtain the information of the type of message that we have to use to publish on this topic. In this case, it's Autominy MSGS speed command. This is the type of message that we are going to use in our program for publishing on this topic at curious speed. We can also do the same for the topic steering normalized. And we are going to obtain the information that we are going to use for publishing on this topic. In this case, we can see that the type of message for this topic is Autominy MSGS normalized steering command. This information is important because we have to import this type of messages for publishing or for creating an object for publishing on these topics. But also we need to know what is the value that we have to change with these messages. So we can use also another command that is rosmsg show and the name of the message that we want to know. In this case, we are going to use first the message Autominy MSGS speed command to know the structure of the message that we are going to use for the topic actuators speed. We press enter and we can see that this is the structure of the message. In this case, we're going to focus on the last field, that is float64 value. And the name value is the part that we are going to use to change the value that we are going to publish by using this type of message. So we have to focus on this parameter for the message where we are going to use the message Autominy MSGS normal speed command. And also we can obtain the same information for the type of message normalized steering command. We can see here again that it has the same structure. We also need to use the part value for setting the value of the steering angle that we are going to use or we are going to publish on the topic actuators steering normalized. Now we're going to analyze the program of the publisher node. First, we can see that we indicate that Python is a environment of programming for this node, and then we're going to import the library ROSPy, that is the one that we use for all the tools that we need for creating our node. Also, we import the type of message speed command. As we saw before, this information comes from the command ROS ROS topic info actuators steering normalized, or a ROS topic actuator speed. This information indicates that we need a type of message with the name speed command or normalize steering command for the topics actuator speed and actuator steering normalized respectively. So that's why we needed to this information before, and we had to be aware of the names of the type of messages that we are going to use for publishing on these topics. Then we use the command by init node to initialize our node. We indicate the name of the node that we want, and then we create an object put speed with the command publisher. We need to indicate the topic of where we are going to publish, that in this case is actuator speed, and the type of message, that is a speed command. And we do the same for the steering angle. We create the object put steering with the command publisher. We indicate again the name of the topic, actuator steering normalize, and the type of message, that is normalize steering command. Also, we create a variable rate with the command rate with the value of 0.2 to indicate that we are going to use a delay of 5 seconds. We are going to see why in the following. And also we create two objects, MSG speed and MSG steering. These two objects contain the structure of the messages that we are going to use for publishing on the topics actuator speed and actuator steering normalize respectively. After that, we have a while loop. In this case, in this loop we are going to do two things. First, we set the value of the object, and we call that we have to change this value for the type of message, the speed command, and also for normalize steering command. So we set the value to 1 to indicate that we want the maximum speed for the topic actuator speed, and 1 for the object MSG steering for indicating that we also like the maximum value for the steering angle. In this case, the car is going to steer to the left, the maximum angle. And after that, we only need to publish by using the object put speed or put steering, depending on the topic that we want to publish. And we use the command .publish and the name of the message that we're going to publish in this topic. In this case, we have MSG speed, and for the steering angle, we have the message MSG steering. After that, we wait for 5 seconds by using the function rate.sleep. And we do the same again. In the next spot, we change the value of MSG speed to 0 to make the car to stop moving. So, as you can visualize, the car is going to move in a circular trajectory for 5 seconds, and after that it's going to stop moving for about the same amount of time, and this loop is going to continue being executed again and again and again. That's all for this while loop of the main function node publisher. Because this is our main node, it's going to execute the function node publisher, and in case of any ROS interrupt exception, we are not going to do anything. We use the function pass, and that's all for the program. So we have to test this program now to verify that the simulator works well and we can make the car to move in the circular trajectory. If this is the first time we use this program, we have to make it executable. To do this, we have to use the command change mode +X and the name of the program, that in this case is program 018.py. We execute and verified. As you can see in green, we have program 018.py in green. This indicates that the program is now executable. We can run the program by using the command run and in this case we had the name pack 01 Autominy. That's the name of our package that we created for our programs, and then we use the name of the program 01a.py. That is the name of the program that we created in Python, and that's all. We have to execute the program to make the car to move. We press enter. In this case, we had to wait a little bit for the car to start moving, and after a few seconds the car is going to start moving. It's going to change the steering angle to the maximum to the left, and it's going to move at maximum speed. As you can see here, there it is. The car is moving now at maximum speed, and it's going to last about 5 seconds, and after that the car is going to stop. There it is. It stops for about 5 seconds also, and after that the car is going to move again for 5 seconds and to stop after that for 5 seconds again, and that's all. That is the first test that we can do by creating a publisher node with our simulator, the Autonomous car, and now we can proceed to make a similar program and to verify that it works the same way for the real vehicle. And thanks for watching.